All right, so you're looking at the bottom of page 10. Okay, so we've talked about domain. Move this around real quick. So we talked about domain. Remember, what x values make the denominator 0? That's what x cannot equal. So while that's what x cannot equal, we use those numbers to then find our vertical asymptotes. Here we were looking at kind of the in behavior of a graph. The notation is what makes this kind of weird. So if you have questions, make sure you ask about it. Okay, we're going to talk about translations later. Okay, vertical asymptote. So this is taking in those domain values and figuring out, okay, where is our vertical asymptotes? I also mentioned something about holes, and that's what we're going to look at today. And then later on, we talked about horizontal asymptotes, and we have 3 rules for those. All right, so a value where the denominator of a rational function is 0 does not necessarily result in a vertical asymptote. There's a hole corresponding to x equals a and not a vertical asymptote in the graph of a rational function under the following conditions. The value a causes the denominator to be 0, but there's a reduced form of the function's equation in which a does not cause the denominator to be 0. So, all right, so if we want to graph this function, f of x equals x squared minus 4 over x minus 2. First off, let's figure out what's the domain. Maybe if I connect my iPencil so I can actually write. So what's our domain? What x value would make that denominator 0? 2. So our domain, x cannot equal 2. Normally that means there would be a vertical asymptote there, but we always want to check to see if we can reduce our fraction. So looking at our original function, x squared minus 4 divided by x minus 2, how can we factor x squared minus 4? X plus 2x minus 2. And that's over x minus 2. Well, what can simplify? The x minus 2's cancel, and we're just left with x plus 2. So here's what that means. We have the graph. F of x equals x plus 2 with a hole at x equals 2 because of that domain. Okay, the domain makes it weird. Okay, so the easiest way to graph this is we need to figure out where, if x equals 2, what does y equal? Well, let's plug it in. So f of 2 would equal 2 plus 2, which is 4. Good job. So that means our hole is at the ordered pair 2, 4. So I'm going to graph that first. So I'm going to go to our graph. I'm going to go to 2, 4. And I'm going to put an open circle. That's a hole in our graph. Okay. Well, now let's graph our function. We have y equals, or f of x equals x plus 2. Well, what's that a graph of? A line with what information? What do we know about it? It's a slope of 1 and a y-intercept of 2. So I'm going to go up to our y-intercept, put a point, and then we have a slope of 1. So if I continue that little line, we're going to graph that like normal, but leave a hole where we drew that open circle. And that's your graph. Okay. Here's the thing. If you graphed this in your graphing calculator, you are not going to see that hole. So you have to understand the concept of the vertical asymptotes and the holes based off of your domain. Okay. Any questions?